Okay, good afternoon, everyone. So, welcome to class two of our training in the cloud computing track. And today we'll be touching briefly on foundations of cloud computing before we now go back to what we learned from last week, basically, right? Um, at the end of this video, you should be able to understand and differentiate, right? So what are we understanding? Understanding about what a data center is and its physical components. We're getting familiar with the concept of virtualization and why it's critical in cloud computing. We'll be able to differentiate between virtual machines and containers, and we'll be familiar with the three core components of cloud infrastructure, right? Um, So let's quickly talk about virtual machines. Sorry, data centers. What's a data center? A data center is a facility that houses IT infrastructure. So when you're talking about servers, you're talking about storage, you're talking about equipment, right? All of these are used to store and process and distribute data. Right? So just sit as a huge building that has servers, that has got storage, that's got networking equipment. I'm just going to show you a picture quickly um, of a data center, what a data center looks like. Okay, let's go to the image section. Exactly. So these are data centers. All of this image, you see lots and lots of computers or servers or networking equipment, right? Let me pick this one. Let me try to bring this one up. Good, right? You see networking equipment, you see servers, you see storage, you see all of these things. Now, all of these things put into one facility or one building is what you call a data center, right? Because what they do is they store as in storage, they process as in compute and distribute data, more or less. We're going to be talking about storage, we're going to be talking about compute and distribution of data later on. But this is what a data center looks like. And what is the role of a data center in cloud computing? Data center is the backbone, the physical backbone of cloud computing. Cloud providers use globally distributed data centers to deliver scalable, reliable, and on-demand service. Remember in our last class, we spoke about getting services from cloud providers, right? All you need to do is go to their website, say, oh, I want this service, I want this service. And in the in a split second, maybe a few minutes even, you have your database, you have your compute, you have your network, you have everything provided for you. If you wanted to, get that yourself, you probably have to import servers, networking devices, switches, routers, cables, and all of these things. And then you have to pay persons to come and install them for you. And then you also have professionals to run them for you, right? But cloud providers already have all of this structured out in their data center that are globally distributed. So Microsoft, they have data centers all over the world. AWS have data centers all over the world as well, right? And all of this, the goal is to now deliver scalable. That is, you're able to scale the application such that even if 1 million persons are using the application, there are no issues. Even if um, 10 million persons are using the application. There are no issues, right? Then reliable, which means it's always going to be there 24/7. Whether you're sleeping or you're awake, you're sure that your service is always up and also on demand, which means you can just go there and buy them, right? So that's where data center acts as the backbone. If they are not running, if this for any reason goes down, a lot of persons and their services, a lot of persons, companies and persons services will go down as well, right? So that's why we say it's the backbone of cloud computing, data centers, right? Um, Yeah. So what are key components of data centers, right? We have servers, like most of all these machines are servers as well as storage, right? They will also have networking. See these cables that moves around that helps to communicate between servers. These cables here, all of these cables. Some of them are hidden, but some are very physical, yeah, right? They are networking components of a data center, right? But these are not just the only components of a data center. You also need power, you need electricity, right? If not, it's going to go down because all of these machines, they run on electricity. If not, it's going to go down, right? Let me see if I can get a physical picture of, let's see what this is like. So that's not what I want. Probably. Okay, let me just search for what I want. So other components of data centers are power and cooling. And the reason for power is what I just mentioned, right? Where I mentioned that they have to be up 24/7. Even when you're sleeping, you do have to be up, right? Uh, so then when you're talking about cooling, um, because these machines, imagine your laptop, using your laptop for like 7 days, your laptop will just start getting hot and hot and hot and hot, right? Now imagine having servers running into thousands, then the room is going to be very, very hot. So they need cooling, right? They need air conditioning units. Sometimes they need some other form of cooling process to run, like liquid cooling. Some data centers um, are embedded into the ocean, like they are dropped into the ocean, such that they leverage the cool nature of the ocean to cool the data center, so to speak, right? Um, Let me see if I can get a picture of that. Yeah, let me see. Okay, so this is owned by Microsoft. Yes, this is owned by Microsoft. This is another one by Microsoft. See what's written the underwater data center. And the reason for this is so that they leverage the cooling nature, the cool temperature of the water to cool the data center from time to time. Let me see. Right. So these are data centers and their components, right? Just so as not to overflow the issue. All right. So moving on to our next slide. But before we talk about our next slide, we're going to be talking briefly about what what people in times past use to host their application, right? So I'm going to, in this situation, I'm going to Google um, servers in the early 90s. Image, okay, sorry, being open. Images. Okay, great. So let me pick one of these images. Give me a second. Give me a second. I'm trying to. Okay, let me just open this. It says 90s server room. Our cloud was straightforward with no fancy apps or AI or any stuff, right? So This, I like the fact that you said our cloud, right? But this is the server room of probably one company, right? And you can see that they have like a whole lot of computers here. And this is what we're trying to avoid in today's world, where you have like a whole lot of computers running different things. Because then you need to have one computer per one service or infrastructure or whatever you're running, right? So you're running a database, you need one computer for it. You're running uh, a service, you need another server for it, right? And probably they all run on different networking stuff. So the overhead cost, you have to bear, you have to buy the server, and then you also have to buy multiple servers for different different things that you're running, right? And that's where tech professionals decided, no, this is going to be very expensive, right? We need to find a way to reduce costs. And they came about what's called virtualization, which is the process of creating virtual version of something such as an hardware or a network or a storage, right? Right. So instead of having a physical server, we thought about having a virtual server because a physical server was going to be limiting them, right? You need um, you need service running on different types of operating system. Then you need to get multiple servers for it, right? You need something running on a Windows operating system. You need to get one server for it. You need something running on a Linux operating system. You need to get the server for it. You need something running on a Unix operating system. You need to get a server for it. But then they realized that if we're able to create a virtual server that can run on one server, then that means you can now have multiple servers doing the same thing. Multiple servers doing running on different OS, running on one application. So let me explain briefly before we move on. So if I open this image that I just that opened earlier, this is probably a MacBook, right? But you can see that they are installing a Windows PC in it, right? Does that mean that you can install a Windows PC in your MacBook? No, right? But you can use something called an hypervisor. Remember, we were going to be talking about virtualization, hypervisors, virtual machines, and all of that, right? You can use something called an hypervisor, which is a software that enables virtualization. There are different types. There's VMware, there's Hyper-V, KMV, and also VM VirtualBox by Oracle, right? An hypervisor helps you to run a virtual machine, right? So you can now run a machine, an operating system, different from your operating system on your operating system. So now that means that your operating system can now run more than one operating systems in it. And that's what virtualization is, basically. A virtual version of something, right? Um, Now, what are virtual machines? Virtual machines are isolated environments or isolated machines that simulate or emulate a physical computer. Each virtual machine runs its own operating system and applications. So it simulates or emulates a physical computer and runs its own operating system. Like this one now is trying to run a Windows 7 operating system. Let me bring this image. So this is a virtual machine. Yeah. What happens when you want to set up a virtual machine is you first of all need a physical server, right? You need a physical server. Then you need a software called an hypervisor. Examples of these are VMware. I don't know if you've heard of VMware. Let me see. VMware. American Cloud Computing and Virtualization Technology Company for that. So this is VMware. It's an hypervisor software that you can use to, run a virtual machine. Another one is Hyper-V, owned by Microsoft, and then there's VirtualBox, owned by Oracle, like I just showed. So now, after the the hypervisor. Now you can run your virtual machine on the hypervisor, and you can run more than one virtual machine on the hypervisor. The virtual machine 1 with their own guest operating system, virtual machine 2 with its own guest operating system, virtual machine 3 with its own guest operating system. So that means that if I have a MacBook, I can run in Linux 1, um, Windows 2, Unix 3, right? So now the drawback we have from the early 90s where we have one PC running as one application now it has been curtailed, right? So what that means is now we don't need to buy multiple servers for multiple applications. We can now run everything on one server because they have their own guest operating system. That's the pro of the virtual machine. That's the advantage. But there are also disadvantages. There are drawbacks or cons to running a virtual machine. One of the cons is that it consumes lots of disk space, right? Since you're simulating an entire machine, you are definitely going to now be requesting for storage space like RAM space, CPU resources from the physical computer. So if this physical computer has a storage space of 1 terabyte, then this guy could request 100 gig, this guy could request 200 gig, this guy could request 300 gig, which in total will be 600 gigabytes of information running on these three virtual machines. Then what will be left for the physical server will just be about 400, right? So that's a drawback. Now, if we also have 32 gigabytes of RAM, this guy could request its own virtual machine 2 request its own, virtual machine 3 request its own. And you can see that the utilization is running up into the red. You can also see that the size is also very big. Now, another problem is the put up time, the amount of time it takes to put up, right? We will now compare this with containers in a bit, but you see that it takes a lot of time to boot up, which is another drawback. Slow to start up. More like it's because you're like booting up a particular computer. So you have to start up the operating system, start up the application, and then go through the whole 9 steps or 10 steps, if you will, right? So that's another drawback. Now, finally, one of more drawbacks that's not captured in this image is that you might require a license, especially if you're running operating systems that require a license, like Microsoft Windows. Microsoft Windows needs a license to run it. So even if you're running with Windows Server here and you have a license for it, you would also need a license for Virtual Machine 1 if you're running a license. So that would be 2 licenses. You need another Virtual Machine Windows, you also need another license. So that means 3 licenses. So even if you're not buying the infrastructure, you're still buying the license. That's another drawback. Now, here comes containers. Containers are lightweight. We'll explain why in a bit. They're portable and they're efficient when you compare them to virtual machines, right? And they share the host operating system kernel, right? So let's go back to our image. You have containers. Remember, so it says example there, Docker. The reason why it says Docker here is the same way you have hypervisors helping to run a virtual machine, you have a software running containers, and that software in this case is a Docker engine, right? Owned by Docker, right? So once you have a Docker engine, you can now run your container. But this is what this is how they are created. So you have a physical server, or you can even run a virtual machine. You can run a virtual machine. You can't host a virtual machine on the virtual machine because it needs the physical server, right? But then you can run a container on a virtual machine, right? Then you also need the operating system of the host. That's your personal computer operating system. Then you need the software that helps run the container, which is Docker Engine in this case. Now you can now run your containers, 3 different containers. The difference between this and this is, while this is a full-blown machine, this is just an application. This is an application. This is one application. This is one application. To explain this, this can be a Windows machine, a Linux machine, or a Mac machine. And uh, this can be Microsoft Word, Microsoft Excel, Microsoft PowerPoint. Now, one difference now is I could run all three of these inside my Windows machine, right? But that's what makes this lightweight because it's just the application. It's an isolated application, while these are isolated machines, right? Now you can see the advantage right on the picture, right? You see the utilization is not as much as a machine, right? Because it's lightweight and it's very portable, right? The size is also not much, but it just takes what's needed for that application, right? But this one is taking a lot of size in expectation that okay, you might run 5 applications, even if you're not running 5 applications, right? Then the boot up time is faster because you're not running the whole OS. The OS is already on. All you need to just start the application, right? So these are the advantages. Now, the drawback, there's also a drawback for containers, right? The drawback for container is that the operating system, right, that you're trying to run on for container one must match the operating system of use. Container two must match the operating system of use. Container three must match the operating system of use. Why these virtual machines do not have to match? That I can run Windows physical server, but then run Linux machine on it. This one would have to match. Now, another drawback is that if this computer goes down, this goes down. But if this physical server goes down, most times the virtual machine does not go down, right? So what I mean is, if I probably get a virtual machine from Microsoft and I try to connect to that virtual machine, if my laptop goes down, that virtual machine will still be on. But if the container is on the virtual machine and the virtual machine goes down, then that container must go down. If the container is on my laptop and my laptop goes down, then my laptop must go down. That's the drawback for containers. Use cases. Use cases. What are use cases? So for virtual machines, use cases includes legacy applications and old applications that require full operating system isolation. So that means you have to isolate the whole application, then you use virtual machines for it. For containers, their use case include microservices. So companies like Netflix, they run on microservice. So like their recommendation engine, their video engine, they all run on different services. And all of those services, remember, containers are isolated applications. All of these services can now become isolated applications that run on their own. Now, they can also be scaled, which means that you can now create multiple instances of those applications or those containers. It's more like you go to a bar and you have one server serving the whole bar or serving 10 persons. That means if the server takes 1 minute per person, that means it will take 10 minutes to serve all 10 persons. But what if you have 5 servers at um, 1 minute per serve? That means you have 2 minutes to serve all 10 persons. You see how faster it has become or how much you have scaled that service. That's what microservices can help. Sorry, that's what containers can help you to do with microservice, right? You can now create 5 instances of one application such that those people can now serve different people at different times. That's an advantage of uh, containers. Now, introduction to compute, storage, and networking in the cloud. These are components in the cloud. You have this cloud machine somewhere here. Sorry, where is it? I'll test I open it. Let me go back. Thought I opened it. Okay, let's see. Data center, the images. Okay, so you have these machines in the cloud. Let me use this again. The components in these machines can be split into three main components, one of which is compute, the next is storage, and the last is networking. Everything in this room can be split into three different components: compute, storage, and networking. Right now, compute would be the virtual machines, right? What they do is they create or they provide the processing power for running applications. Right? So to be a virtual machine can form part of a compute. Then for storage, you're probably talking about object storage, block storage, and the rest of them. So probably like uh, S3 storage or database or Elastic block storage from Amazon or Azure, what's this thing called again? Oh, I've forgotten again. Anyways, coming to me by, I can, let me see if I can do it. Azure, sorry, I said it in the last class actually. Storage. Yeah, Azure blob storage, yeah. So we're going to be looking at this throughout this through this course as well, right? So now, how do they communicate with one another? So you have a virtual machine that needs to store information. You probably need a storage resource like an Amazon S3 or Azure Blob Storage or a database like SQL Server or MySQL and all of that, right? Now, the communications between all of these guys are done by networking components, right? The access to or no access are done by networking components. So networking components like virtual private cloud that gives access to resources or no access to resources, right? So basically, these are the main components of a data center: compute, storage, and networking. Let's not forget those three. They work together to deliver cloud services. So to wrap up this part of the class, we're just going to go back to the beginning again, see what data centers are. They are facilities that help to house IT infrastructure like servers, storage, and networking of equipment. And they're like the backbone of cloud computing, where they deliver scalable, reliable, and on-demand service. The key components are servers, storage, and the networking. Right? Then when we're talking about virtualization, is the ability to create virtual version of things, like virtual machines or containers. For virtual machines, software that's used is called an hypervisor, but for containers, called Docker engine, right? Um, virtual machines are isolated machines, while containers are isolated applications. Then we also touched on briefly on introduction to compute, storage, and networking cloud. So let's see what we can achieve now. Let's go into Azure. I'm not sure if um, but I think I got a message that we completed uh, account creation. So I was able to finally do that, right? And we can now look at all the resources available on Azure. So let me see. Let's go to all service. wait for it to come up. All right. So, okay, virtual networks, databases, storage, app service, and all of that. But let's go to compute and see some of the compute uh, resources. So you can see virtual machines, skill set, virtual machines, uh, app service, uh, VMware solutions, container apps. You know, most of the things that we've talked about, they are under compute, right? Uh, then when we go to storage, okay, so for storage, we have PC, object and file block storage, okay? So we have this, um, storage accounts, right? I'm actually looking for Azure Blob Storage. So I think it's actually on that databases. Let me see. So these are other storage platforms. Hold on. Okay. So I think storage accounts is where we have blob storage. Yeah. So the networking, so you have DNS private resolvers, networking interface, NAT gateway, public IP addresses, and all of this other stuff, load balancer, application gateway, and all of that, right? So there are a lot of stuff in here, but just test, you know, with one of these, we're going to be creating a database. Then probably in our next class, we're going to be creating a virtual machine. But in this class, let's create one database. We're going to be creating an SQL database. Let's see. We're going to test it out. Okay. So let's create an SQL database. So you see, when I say on demand, just I'm just thinking, oh, let me just create one. Because if I'm at the store trying to create one, um, not working, let me go back out and go to yeah, create it here. Okay. So I will just say create database. So I would use the free resource. Okay, so they're saying want to try Azure SQL database for free, create a free serverless database with the first 100,000 visitors, seconds, and 32 gig of storage and 32 gig of backup storage free per month for the lifetime of subscription. Limit 10 free, limit 10 free database per subscription. So I'm able to create 10 database for this number of visitors, seconds, and storage. It's 2 gig of data. Right? So let's apply this offer. Now, this is our subscription. I created my subscription this morning or yesterday, I can't remember. Now, I need to create a resource group, so I'm just going to call it Salesforce Test Group. Let's see. Then I need to create a database next to Salesforce DB. Also create a server. To create a server for the Salesforce. DB dot database blah blah blah. Right? Um, use Microsoft Azure authentication. Use both SQL. Let me use SQL authentication. Uh, scale code. You have to remember if you create this, you have to remember the username and password. Right? So you have to remember this because we're going to be using it to log in. So I just created the server. Now, saying behavior when free offer limit is reached, I want to auto pause until the next month, right? Then, what else is he asking of me? Let me see. Choose how to blah, 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 blah. So I can either just review and create, or I can go to the next tab, which is networking. So let's just go there and see. So connectivity, network connectivity, I don't want any access, default use, the direct policy, da, 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 da. Configure how clients communicate with your SQL Server database. So I'm going to use default for this. Leave this as TLS 1.2. Then security, um, get started at 30-day free trial period, and then $15 at this. So I'll say not now. I don't need Microsoft Defender yet. Ledger, done with this. So I don't need most of this stuff because all I'm trying to do is just create uh, a database. So I'm going to leave this as it is. Then go to additional settings, data source, ground sample data. So I don't want sample data. I'll create my data myself. Um, database collection, blah, blah, blah. I'm going to leave this as is. So I'm just going to leave this. I don't want to disrupt any other setting I've done because I don't want sample data. I'll create data myself. Tags, I can give it any tag just because if I have a lot of databases, so I have tabs for them. You can read this later on to learn more, but I don't want to do that. Then review and create. So estimated cost, there's no estimated cost right now. Every other thing looks fine. So I'll just create this. So it's validating now and initializing deployment. So just going to wait for all of this to happen. And you see that in a few seconds, we would have our database. Imagine if I wanted to buy a server and all of those things, I wouldn't be able to achieve that, right? Deployment in progress, all of this in a few seconds. Deployment stage. Why? What happens? So it's sad, but it's happening. Let's see what's happening. So I think what is happening um, is because I am presently in Nigeria, they are not allowing me to make this. So what I'm going to do is let me try something else. I'm going to leave this here. Let me try something else. Let me try creating an app service and see what's going to happen. If they're going to allow me to create it. Okay, so these are regions where their data centers are located. So I'm going to pick something related to Africa. Let me pick South Africa. Okay. Let me explore their pricing plans because I want something cheaper or almost free. Let's see what we have. Okay, so for dev test free, I'm gonna pick this. Yeah, so I'm gonna pick this. Okay, so I'm gonna leave it as free test service. No, don't create a database. Deployment, auto cabling. The funny thing is, there was a time I could create all of this stuff easily. So the problem now, working with foreign companies and working from Nigeria. So enable application insights. Let me just leave it at no. I don't want anything that would cost anything. And yeah, let's see if this work. Estimated price is free, right? So I'm going to pick this. Let's see if this will work. If this is free, then I can also price this the free version of the XPSLY instead of the other version that it talks about. Probably that would work fine. So initializing the deployments. So let's wait. I think it's gonna work. Let's wait and see what's going to come up. Still running. Let me see if I can check logs. Hold on. I think it's fine actually. Yeah, it's fine. So this just got it. Okay, so the details. Okay. So we're just going to wait for it to give us the deployment complete fine. Then we'll go from there. Ah, yes, deployment succeeded. So this worked. So let's go to the resource, and then it would show us what. So what I did is a resource, a compute resource without storage, but there's some sort of networking in it. We're going to open it up and see. So this is it, and the domain to access this. That's it. So if I paste this here, it's a website that I just created, and you can now, I can probably now deploy to this website, change it to whatever content I want to be reflected on it. So while that is trying to open up, because I think it's still working, you can now look at some other things like, okay, let's look at here, monitoring. I didn't enable monitoring, so I'm not sure if it's going to work. Okay, I'm not sure it's going to work, or maybe it's still pulling stuff. Logs, capabilities, notifications, and all of this stuff. Deployment center, if I want to add SSL, um, custom domains, like if I want to put, because right now the domain is that, so this is the website now. The domain is secure, but the domain is this long URL. If I want to put like www.scalefort.org, I can now do that using custom domains and some other things basically. Then let's see what we have here. There's so many other things that we can now look at here. Deployment slots, settings, authentication, custom domain certificates. Now scale up to increase. Remember, I did test, so the instance is just a small instance, right? But I can now scale it up to create more. I can check the performance and all of that stuff, monitoring and all that stuff. But I can't really check the networks, right? I've been trying to look at that. So let's go home and let's try to create a new database. But this time I'm not going to use that their free resource. I'm going to get a free resource myself. Let's see if that works. Okay, so I'm not applying the offer. Database name, second, to test, server. Then I created one again. Just have to create another one. Still, first, second, server. Uh, the suspicion does not have access to create the server in this selected region. So let's look for that region. Interpreter notes. Okay, I'm allowed. Use basic this. So remember, I said you have to remember the password and the username. Okay, then let me see what we have there. Last we know workload development, configure database. So let's look for the one with free stuff here. So all of this now, their price. I need something to change configuration. So hold on. Let's go back to development, configure database, basic, build. I can use this. Here we are. It costs, it costing me some. It's not change. Okay. not changing. So let me see what's going to happen. Let me press to apply this first. Configure database again. Okay, you know what? It's not changing. So it's supposed to change. I guess maybe because the data that's free one. Okay, you know what? Let's go back. Let's try the free one, but try the change the location. I'll say the location will help. So apply offer, then press go second inside this. Take the server second. So now if I specify this area one and so let's see South Africa, where are you? So it's not even there. Let's see South Africa. Uh, okay, let's try Europe. Oh yeah, there you are. Second video still first. Use this. So, okay, let's see. Auto pause. What else? So now with you and create this, let's try this again one last time. So initializing deployment, deployment in progress. Okay, I think it's gonna work this time. It's taking longer. Okay, we have a green tick now, so that means we're almost there. And another green tick. Waiting for the final one. So I guess the issue was because I used the location that I'm not allowed to, right? So now I am using South Africa and they're allowing me to do that. So let's see. I want it to completely deploy so that we can now go into it, talk about networking and the rest of that stuff. Good. It's completely deployed. Let's go inside the database. We can connect to this database externally, and I'm going to show you how we can. Uh, but let's see. Okay, let's first go into the database. Log in. Okay, so an instance, blah, blah, blah. So it's not allowing me log in because of, I think, the network issue. It's not recognizing my IP address. So I'm going to have to look into this briefly. And let's see. Okay, configure access. Yeah, so let's configure who is allowed to access. So we'll go to security and all of that. So say selected networks. Now we can now add rules to this database to see who can access it, right? Um, so it says I can add my IP address or a firewall rule. So let me just add my IP address to this and save this. Now, what this means is that I can access the database, but if I were to give you the connection string and all of that, you won't be able to access the database. And that's a security process or procedure that's put in place to allow us not to allow our database to be secure. So now let's try accessing it again. We have to go back to the query editor, coming, and find it in the sidebar. Next second, trying to look for query editor. Sorry, I used it just not quite long ago, and now I can't find it anymore. You know what? Let me just go back, 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 in, and yes, so all of a sudden I couldn't find it anymore. Anyways, let's try logging with the phone. So now I can log in, right, as you can see. Um, I don't have anything in my database yet because I've not created a table, but I can create a table. Um, I can create a table so easily. Using SQL, I can say create your table and create the table, but I want to show something else. Let's see, let's go back to the overview and this time show the connection string. I'm not supposed to show this because using this, people can access your database. People can access your database. However, because of the other networking um, security that we did, where I'm only allowing my IP address to access it, then I would not, then I will not have an issue, right? But then even at that, you're not supposed to show your connection string to just about anybody. So now I want to try to access this from a different resource on my PC, right? So I'm trying to open up the software called JetBrains like that. I'll delete this all of this resource after this class. So even if you try to access it again, you won't be able to get it. So let's see. Um, I just need to come on. Trying to okay. Let me just open this. That's like the most easiest to open all of that. So we're just waiting for it to come up. With it. So while that is even happening, let me go back to networking. Now I can find networking. So the UI is a bit messy. Trying to look for networking now. Okay, so anyways, this I already have shown what the query editor looks like. I'm pretty sure probably later on when you want to create yours, you wouldn't come across most of these issues. But I want to remove my IP address temporarily before let me see, before trying to connect on here. So now let me try to connect. So this is a browser called JetBrains Rider, but then you can also use this browser to connect to a database. So I want to try connecting to our database. Okay? Let me use the connection string. Okay. Okay. Great. So I'm going to have to pass in the password somewhere here. Yeah. So I'm going to pass it off screen. Give me a second. Bring back in and test this connection. Let's see, it's not supposed to connect because there's no access. My IP is not whitelisted. It's supposed to have been like a feedback already. Okay, test connection succeeded actually. But why is it? Did I delete it? Right. Okay, I didn't save actually. I didn't save. I deleted, but I didn't save. So that's why it's still connecting. My bad. All right. So, anyways, so we're able to connect to the database. So I'm just going to start this. Maybe my IP address is still there. Still loading and coming up. Then I will create a database here, and let me create a database then test VB. Then just create that. So the reason for doing this, I just want to test to see if we're going to see this database on the cloud when we are done. Just trying to test what our operation. So it's taking a bit of time because communicating to the server or the data center that is in South Africa. So there'll be a lot of network calls and all of that. So I'm trying to get the server in South Africa and then give a response back to you, right? And also that's also dependent on my internet speed as well, right? As well as my resource on my laptop because you can see that the laptop is also processing some other things, right? So I'm going to allow this to continue what it's doing while I go back to the query. Go back to the query editor and try to connect here to see if we've actually created a database called TestDB on the cloud. So now let's go inside tables. There's nothing in here, actually. Let's go back here. Reload this. Okay, done. Code successful. Everything that so it's actually not created yet. So hold on. Okay, and let's try to create it again. Database. This time I'm going to make another one. Text two and okay, let's see. My PC is also lagging, so it's taking a bit of time. It's not supposed to take this long to create a database. However, let's just be patient with. Okay, I'm going to log in again. Okay, let me reload your page and reload this while at it. Because I created two databases or tables already, and they're not reflecting anywhere. So I think I need to close up a few things so as to create space for my laptop to run properly or efficiently. So logging in here and why is- that's that's bad actually. Why is it there's no database? I guess it has to do with my system, not the cloud, but this okay, let me try something. Let me try something. Let me use the scripts used in creating a database here to create a database in the cloud. See what looks up. Yes. completely. Run this. So it's running here. 10 seconds, 11 seconds, 12 seconds. So while that is happening, close this and wait 22 seconds, still going. Uh, oh, okay. Delete all databases. Um, this still running. Okay. We have created it in the master. Let me try this. So this is okay, succeeded. So now it's created here and still not showing. Load. Okay. And already exists. So the database already exists, but I can't see it. It's probably a connection thing. So and I want us to okay, you know what? Let me connect again. Let me connect to the database, the connections thing. Yeah, need I need the connections from Ash. Okay, it's overview. Just log out of it. Get the connections frame, copy this, paste it here, uh, put in the password, hold on, that's the bits. So connecting now. While that is happening, let's go back to the query editor. And since we've gone full circle again, let's see if it's going to work. If we're going to see the database is there. You can't find it. Okay. Let's see if we're seeing it. If we're going to see it here. Databases, no database selected, all database. Then check master. Okay, I'm not opening it up actually. Schemas, save that later. I'm not selecting to see everything. Select everything, all schemas and everything. So, alright, let's get to video. There's nothing inside it. I don't see everything, but I'm not seeing that. But they're there. It's there actually. Let's get inside master. Selecting everything. Okay, it's reloading now. See if that's going to open up anything. While the query editor here is actually messing me up. I'm not sure why. So I'm going to just, I want us to try this. So I'm going to give you the assignment. The assignment is Let me pull up the assignment. Netflix. I'm pulling up the assignment while this is loading. Still loading. It seems to have stopped loading. So let's go here. It's actually weird. The database is there, but you can't find it. Database address. Shouldn't be in there. Should either be in the under masters schemas. So there's something under the schema. All schema. All schemas. Okay, I wasn't selecting all schemas. All schemas. Okay, so I wasn't selecting all schemas. Okay, let's see. Now let's reload it. Now, so for our assignment for two, I want us to research and write a one-page summary on how cloud computing differs from traditional IT infrastructure. You might want to do this, you might not want to do this, but it's kind of going to give you insights into traditional infrastructure and cloud. Then identify three real-world examples of infrastructure as a service, platform as a service, and software as a service. Add that inside your one-page summary. Three real-world examples of infrastructure as a service, password as a service, and software as a service. Then finally, just go around the platform, create an app service as well as a SQL Server database. Just same way I did it, and then play around with it the same way I'm playing around with it. Right? Let's see what you would come up with. And it's really sad that I can't see the database, even though it's somewhere. It's here somewhere, but it's not being visible. I think it's because of the way the filter works. Because under the schema, there's something, but it's not showing. Database, default database, master. So I think there is a problem with the connection that is not making it allow allow us to see the database. Attempted to introspect database master with connection to database might end with what? Azure error. Okay, so there's an error that's been stopping us from saying it, right? It's coming from Azure. Uh, Coming from Azure. So just try this and see if you can create a database and see the table, and we'll go from there in our next class. Thank you very much. I'm going to be deleting all of these resources after this call. Bye for now.